Hi everyone, welcome to our latest episode of GoingNative. I'm Gabriel, as always.
And I'm Steve Carroll, I'm the dev manager for Visual C++.
So Steve, what are we going to see today?
So about 3 weeks ago, the ISO CPP committee got together in Lenexa, Kansas, and as usual, Microsoft sent about 6 to 7 different people to participate in that conference in various guises. So today we want to update you guys on the progress that the CPP committee made in Lenexa, Kansas. This is a follow-up to a conversation that we had in a GoingNative episode with Gaby a few months ago, I think it was, where we talked about what happened in Urbana, and now we can see what progress they've made since then.
This episode has a lot of content on what's up and coming with the C++ language. We've done our best to outline everything in the description below. Hope you guys enjoy.
Okay, everybody, welcome back. We came to you about 6 months ago after the Urbana C++ committee meeting, and now we're here back in that series to talk with Gaby and Artur about how things went down in
Lenexa, Kansas.
Oh,
beautiful
sunny
Lenexa, Kansas. Oh,
Great.
yes.
I am a born and bred American Midwesterner, and I have personally also never heard of Lenexa, Kansas, but now I know it is a hotbed of C++ action.
Yes.
All right, great. So, more progress made towards C++ 17 at the committee. I think one of the most important things that I wanted to go through today was sort of the framing for what is C++ 17, which I think Bjarne Stroustrup.
Yes, you're right. Just a couple of weeks before we get to the meeting, Bjarne sent this note to the Standards Committee Refactor, and that escaped to the wires. So basically, he was concerned about the work we were doing for C++ 17. For 98 and 03 and 11 for 14, he could articulate what it was we were trying to do. But for 17, he saw a lot of work, interesting work coming out, but he thought he needed a way to articulate a coherent vision. So he had 3 major areas that he would like to see progress. First is support for large-scale dependable software. And the one is high-level concurrency. I'm looking at Artur, who is expert there.
And highly concurrent.
Yes. And the last thing is simplify the language used for people who write code on a daily basis. The rules, how to simplify, how to use the STL, and a bunch of other corner cases.
Got it. So we have 3 major themes for C++ 17
Yes.
overall.
Mm-hmm. Yeah.
Are we confident that it is C++ 17 at this point? Can I stop saying 1Y and confusing people?
We can get 17, and I would not want to see what we did for 11, which was OX, and extern hexadecimal. That should never happen.
So
again.
I have your personal guarantee that we will not slip into the
First,
the twos.
I'm not the committee.
Got it. All right.
But,
But I am your boss. No.
You are.
No.
No, for the part that, we're involved in, which is we're driving some of the major areas. If you look at Bjarne's top 10 list, get there shortly. We're actually very active. Artur is driving the concurrence library parts. I'm heavily involved in the language aspect, and we have a bunch of folks, going around and making sure things happen. And if things turns out, C++ 17 will be a very, very good language to use.
Great. So you alluded to a top 10 list.
Oh, yeah. So in Bjarne's note, he came up with 10 points he would like to see work on. So the first thing is concept. Yay! Yes, concept. In fact, we already have going on, it's probably done yet now, I think. Concept live, technical specification ballots going on. And so far, the returns we've seen, the comments are looking pretty good, and we're pretty confident that we'll get some.
Can you give me a 1-line introduction to concepts for 20-haired managers?
Concept, essentially, if you're trying to write, generate functions, algorithms, you want to make a requirements on the type that you accept as part of your algorithm, and concept allow you to specify that directly in code.
Generics.
Yes, you want to. It's more than that. You want to specify directly in code what it is you expect from the type, and have the compiler keep you honest. And you also want to build tools around that. It will going to make generic programming fantastic.
It's like is comparable.
Yeah, it is comparable. Can I copy this and actually require that I want to apply this predicate? Say, find if, for example, I get a predicate. I want to make sure that the predicate I'm given actually accepts the type as argument and returns bool. If you want to accumulate values in the sequence using the binary plus operator, you want to express that directly in code.
Got it. All right, what's number 2?
Is module. Yay! So finally, The standards committee is looking very seriously at providing ways to structure your code directly. You take dependency on standard math library, for example, or in different vendors' library. You want to express that directly in code. So the 30,000 feet view of module is you're going to be able to write in code is structure, express in code is structure of your code. If you take a dependency on the standard library, you're going to say that, well, import standard math. The major thing is that we want to minimize use of header file. So, copy and paste. Hash includes stdlib.h is basically asking the compiler, go look at that file and copy the content, put it back in my source code. That makes the compiler work very hard. The parser works very hard to parse that information. If you have templates instantiations, they get instantiated several times, and then the linker has to work very hard to throw away most of what you've done. So that's a lot of duplicated work, and modules are going to make that much simpler to do.
Imports of modules instead of pound includes for header files.
Yes.
Improving the compile time because of...
You're going to be isolated from macros. We know macros, they're evil. They're really evil and shouldn't use them in code. But today we don't have much. And with modules, you're going to minimize reliance on macros, or at least their effect, right? And you're going to have componentization. I mentioned this earlier. And more than that, you're going to have semantics-aware tools for developers. People love the experience that people have with the C# compiler. You can get the same thing with the C++ compiler if you have a good module system in place.
Got it. All right, number 3.
Ranges, yes, this is fantastic. This work being done by Eric Nibbler. He made several presentations. The idea is, today when you call standard library, let's say find a value in a sequence, you pass in a pair of iterators. That's very low level. You just want to say, well, here's the sequence of stuff, find that value in there. And ranges is this library component that allow you to express this very simply and effectively. And it uses concepts too, right? So we'll get concept, we'll get ranges, and you'll see C++ would be a really, really good language. So the next thing is uniform call syntax. So if you look at the standard library today, we have containers like vector, list. They have begin, end to tell you the beginning of a sequence, the end of a sequence. Today they are provided, at least in C++ 98, when the STL started, they were provided as member functions. And then by C++ 11, they became some form of global functions. But what we have seen is that we have the dot notation, which is what object-oriented folks use. It's very nice. And then you have what I call a functional notation, more mathematical. It's very general. And we have seen a move from member functions to free functions, so that in the end, when you write your generic algorithm, you have to express what it is you want to require. Do you want the begin to be a member function or a free function? If you require both, then some of the containers will not be able to satisfy that. So you end up with either double the size of your requirement or an impossible requirement to make. So the proposal here is to say, well, if you say v.begin, and if there is no begin member function, the compiler will try to call a global function, and vice versa. So this unifies the call syntax. It doesn't really matter whether it is a member or free function. What matters is that they perform a task and the meaning of the task. So this is a way to make it much simpler to write, generate programs, and make concept more effective. Next on Bjarne's list was coroutines. We had several proposals for coroutines. So what's the coroutine? So coroutine is essentially like a function, except that when you call it, it gets in there, it gives you a value, and then wait till you ask for the next value. So we have this yielding value, and do this repeat until you're done, and you say, well, I'm done, go back. So that's the basic idea. And coroutines have been around for a very long period of time. They were part of Simula, which is the father or grandfather of C++. And finally, we'll get them in C++ 17. And like I said, C++ 17 is going to be a wonderful language to use.
Did we do a talk on await yet? Did we do await?
No, we need to go do something on that. And kind of. So we actually do have a proposal on the table and work being done by Gaby and here at Microsoft, yes, and on the C++ team. And he has an implementation that is very skilled, very efficient. Soon it will be out, and I hope folks get their hands on it. I know that the Clunk folks are also implementing coroutines. So this is going to be widely usable by the entire C++ community.
So this allows you to do not just yield return styles.
Yeah, so you're gonna so essentially co-processing, taking my job, which is
but
compiler
also
writing.
asynchronously.
Yeah, asynchronously, yes. So if you take compiler writing job, you have Lexer parser, the parser asks the Lexer, give me some more tokens, and you do this, it's kind of cooperative, concurrency going on. I'll talk to you more on that.
And if you're kind of a C# developer, you'd think about this as sort of a combination of yield return and the await keyword.
Yeah. Do you want to add something?
No, I think you've covered it. And there's a nice integration with that, between that and futures. That's part of the other proposal that we are putting forward.
The sixth item on Bjarne's top 10 list is good support for networking. There is a proposal that was discussed at Cologne meeting that every February, yes, and then it was discussed again at the Lenexa meeting. I wasn't in the Library Evolution Working Group, we call it LEWG, but it is a well-received proposal that's being scrutinized, and hopefully we'll get good support for networking. The seventh item was contracts. So what are contracts? So essentially, we are talking here about what happens to your program when you make mistakes, have bugs, right? Usually, you have crash. That's when you're lucky, you get crash. Sometimes it goes on a while till you get something really difficult to debug. The idea is to provide some language support for early containment of bad behavior of the program. We did have a proposal that tried to put together the static aspect, what happened compile time, and runtime aspect, which is, if the compiler can't tell you what should happen at runtime. That was very well received, and concurrently to that, there was a proposal from Bloomberg, which focused more on assertion system, and the Evolution Working Group voted why they liked the proposal we had. They also voted to direct both Bloomberg and my team to come together with a unified proposal for Kona, which we in October, and we are working very hard on that.
So it's an assertion system combined with preconditions and postconditions?
Precondition, postcondition. So what's the precondition was what your function expects. So for example, if you have the bracket operator indexing to an array, you expect the index to be in bound. So you can state directly, this function expects its argument to be less than size. And the compiler would understand that. The static analysis tools and runtime analysis tools will understand that. So this is not comment. We're moving comment from comment to something closer to mechanized scrutiny. And similarly, you have post conditions too, which say, after you call this function, we guarantee that this condition predicate holds on the state of computation. So for example, if you construct an array view from a vector, you have this guarantee that the data pointed to by the array view is the data from the vector. The eighth item on Bjarne's list is SIMD and parallel algorithms, and I think I'll turn to you to explain that.
Yeah, thanks, Gaby. So C++ 11 and C++ 14 have made important advances in that space. For the first time, we can actually create a thread in a portable way. We understand what a data race is, and we can reason about how our atomic objects interact with hardware, right? And that's incredibly important. But still, this is still very, very low level. How do I sort an array of integers or floats and fill all my CPUs with useful work? We still don't have an ability to do that in a portable way in C++ 14. So the way that the standard approaches a problem like this is, in the concurrency space, we start building what we call TSs, technical specifications. Technical specification is a non-normative document that we specify, and then different vendors can build the implementations according to that specification. Sometimes when a proposal is presented to the committee, a committee can vote directly and accept it into the proposal, and we hope that this is what's going to happen with modules, for example. Sometimes there are features that we want to experiment with a little bit. We want to build them on different platforms. We want to see how they work. All of this is done to ensure the quality of a standard. When the time comes to airlift those features from the TS into the standard proper, we will make sure that they are implementable and that the specification is of really high quality. That's what we call a TS. There are two TSs currently in flight. One of them is called a Parallelism TS. We also call it a Parallel STL. The other interesting TS that is coming up is called the Concurrency TS.
Mm-hmm. And who's the editor for that one?
It happens to be me.
Okay.
Yeah.
So you might know a thing.
Yeah, I know a few things about that. Concurrency TS, the basic theme of the concurrency as opposed to parallelism is concurrency is about composing things that happen concurrently, not necessarily in parallel, right? Whereas parallelism is about just filling your machine with work, right? Squeezing as much juice out of your CPUs as you can. Concurrency is about, I have this concurrent operation, and when that operation completes, I need to go and do some other operation. In the current proposal, in the V1 of the proposal, we have 3 parts in the TS. First part is called Improvements to STD Future. For those of you familiar with the PPL library, you already know the concept of a PPL task. It's something that you can instantiate, and that task represents an asynchronous operation. Once that operation completes, you can attach a continuation to it, and then that continuation will execute with the value that that operation yields. And in addition to that, you can compose asynchronous operations by doing a join of 2 operations or choice. Like if operation A completes and operation B completes, only then do you execute this, right? And choice would be, if A completes or B completes, then perform an action. This has proven very successful for Windows 8, and with that, in fact, we like it so much that we want to make it available to everybody else outside of Microsoft. And so PPL was the kind of the inspiration of that proposal. It just so happens that in the standard there already is a very suitable concept that we can just augment to make it closer to PPL. It's called a future. What Herb calls it, a ticket redeemable for a value. It's a proxy of an eventual value, right? It has methods get and wait on it, and we're just adding one method, the then method, right? So you call future.then and then put a lambda in it. And that makes it very easy to compose multiple asynchronous operations in a wait-free way.
So you want to do an operation, then the next, and there's some kind of join.
Exactly. So .then is a way to chain those operations in a linear way. PPL tasks are different from futures in that in future we have a unique future called just STD future and a shared future. And that adds some additional complexity, right? And this is also the reason why we first want to build it into the TS. So we build the specification, we implement it according to the specification, and we'll see how that works. We are very confident that those concepts are useful, they're implementable, but having them in a TS allows us to work out all the kinks, right? If there are some inaccuracies in the specification, then an implementation will definitely uncover that, and we'll have a chance to fix that before it gets into the standard.
Okay.
This is the first part of that.
Oh.
You thought I'm done. No, I'm not done yet. So there's 2 other things in the TS. The second thing I want to talk about is called latches and barriers. Right. This is part that was not pioneered by us in Microsoft. It was actually suggested by 2 other guys, Olivier Giraud and Alistair McIntosh.
Yeah, they're from NVIDIA.
And Google. Yeah. And the idea is to make coordination between threads a little bit easier. Like we already have a concept of a condition variable, but condition variable is kind of tricky to use. You have to use 2 different kinds of lock guards and mutex, and then typically a variable that you guard with that mutex. You have to remember to write your predicate in a certain way to work around the spurious wake-ups. So it's a little tricky to use. And so a latch allows you to coordinate different threads in a much more straightforward way, in a way that is less error-prone. Mm-hmm. So it's sort of a higher level abstraction over a condition variable. High level, but still low overhead abstraction.
Close enough to the machine so that you
perform. It's still close to the machine, right? We're still C++. We're still talking 0 overhead abstractions. So that's useful. And finally, the other thing that we've discovered that would be useful to have, Herb Sutter was the author of that proposal, is called atomic smart pointers. It's a shared PTR that also happens to be atomic. And by introducing this concept, we make certain patterns of log-free programming easier and lower overhead.
Yeah, mainstream and easily accessible.
It's something that people know how to use today, but they have to certain follow rules, and the implementations are not necessarily as fast as they could be. And this just, it's a little thing that helps people in particular
more
patterns.
approachable by ordinary programmers.
Is it the transfer of ownership of the unique pointer that becomes atomic?
No, it's just your shared PTR becomes atomic by introducing this concept of atomic shared PTR. You don't have to have that today, right? You can always perform atomic operations on a regular shared PTR, right? But by having an atomic shared PTR, first it becomes less error-prone because you never forget to apply an operation on it, and we can also implement it much more efficiently in the library.
Got it.
The next item on Bjarne's list Is, well, just make the library much simpler to use, especially at API boundaries. Like you want to have string views, array views. So they're just some kind of fat pointers, if you wish, into a vector, into a string, and it's a pointer that, for a string, it knows the starts and the ends, and so that you never forget to you won't fall off, when you're working the string. So these are data types that are already parts of the fundamental.
It's library fundamentals,
library
TS,
fundamentals,
also TS.
So a nice thing about this list that Bjarne had was that most of the work we're already doing, and he just needed a way to focus, to have very good mental model about what C++17 would be. And the last item on the list, and something that's very important, is, well, sometimes when we're writing programs, we get data in and we want to operate on data just locally. So we like to have an array of items locally on the stack. So go say on the stack, right? And we know that once we get the vector, or that array, it's not going to change size. So this is not like your usual vector. It's going to reallocate it. You don't get to parameterize by funny allocators. Just very simple, array. It constructed with the right data, the right amount. It doesn't change. It doesn't, move around. Just stay where it is. And we almost got something like that for C++14. Array of runtime bounds and something called done array. And for some reason, they got taken out of the standard into separate TS. But no progress was made. Now we really, really love to have the very simple data type. Array on the stack, I have 10 elements. I'm not going to resize and just want to work on that stuff. Once I get out of the function, the array is gone. We don't have a concrete proposal for that yet, but we are working on it, and I'm pretty sure we'll get something for Kona or near after Kona.
Okay, so what's next for the committee?
Well, the committee is going to meet in October, I think the 24th.
Where's that one? Is it also in the Midwest, or?
It's in Kona, Hawaii,
yeah.
right?
Oh, that's rough.
Yes, very, very tough. But let me tell you something. This is not what you believe. This is not the C+ team going on vacation. I can tell you my experience
Without
from
the
2007. Yes. So in 2007, we were locked in this windowless office, and the AC was on. Very high, so don't get your hope up.
Okay.
Yeah, so Kona is actually very important. Now we have basically at Lenexa, we decided that, well, C++17 is around the corner. We're kind of pointing out whether it's going to be 1, Y, or Z, or that kind of stuff. No, the committee decided no, they really want 17, and they decided to meet 3 times a year as opposed to 2 times as we are doing now. So after Kona, we'll be meeting 3 times a year. So for Kona, if you're going to, if you have a big proposal for C++17, your time frame C++17, then make sure it makes Kona, okay? If you can't make it, that's fine. We are going to have C++20, just like we had 11 and 14, where 14 is a bug fix to 11. C++20 is going to complete 17, but we need to get 17 out of the door. And I suspect Kona is going to be that meaningful. I'm not the convener. Herb is the convener, but that's my feeling.
So if people are interested in getting involved in the committee, how do they get started?
So the simplest is, well, you go to isocpp.org. You have the list of forums. The next thing, if you want to muscularly contribute, get into contact with your national body representative. I think they also listed on the Standards Committee website. I can tell you about US and France.
Who does US?
US, that would be Barry Hedquist, and this is the PL16. Yeah. And for France, you contact AFNOR, and I don't know about the.
Start by participating in meetings, write proposals, and it's better to be there in person to present your proposals.
Yes.
But that's basically how it goes.
Yes, and be fearless. Now, come with your proposal. If nobody is there to defend your proposal, it will not be read and discussed. Okay, you have to be there because everybody is making an effort to come there. And please don't send us memoir or PhD thesis that are over 200 pages.
That never happens.
Well, we've seen some.
Okay.
So in between now and Kona, you also have CPPCon, which is the conference for C++. Summer is coming, and CPPCon is around the corner. And Hope you
Summer
make
in
it.
Redmond is beautiful.
Yes, it is. And I hope to see you at CPPCon and Kona.
Yeah, same here.
So that's our wrap up from Lenexa, Kansas, and we look forward to doing another one of these for Kona. So if you have any feedback on this format or the kinds of things that you'd be interested in, as always, please leave a comment below.
Thanks for watching.